Hello everyone, this is Nilima and in today's video I am going to discuss the periodic table. This is a modern periodic table. Periodic table is a framework for organizing the elements in rows and columns so that elements with similar properties are in the same column. By the mid 1800s, scientists has discovered around more than 50 elements and determined properties of each. Now, they need a way to organize all the information. They tried many ways, like they tried to arrange them in alphabetical order. But whenever they found a new element, they have to rearrange the whole uh, whole order. They look for arranging the element according to their color, but there are many elements which are of the same colors. In the late 1860s, there was a Russian chemist named Dmitry Mendeleev. He was also looking a pattern for organizing the element. So he placed the element in the increasing order of atomic mass. Atomic mass is the average mass of isotopes of an element. And what are isotopes? Isotopes are the atoms of an element which are having the same number of protons but different number of neutrons. So atomic mass is the average mass of these isotopes. So when Mendeleev arranged the elements in the increasing order of atomic mass, what he noticed that that properties repeated in a pattern that allowed the element to arranged in a table. And since the organization sorted the properties of element in a pattern of regular period, so the Mendeleev organization of the element are called periodic table. Since the elements are arranged periodically. He also left gaps in this table wherever he thinks there is a break in the pattern of the properties. Although most of the elements are in a pattern, but there are some which are out of order. For example, if you look in this table, this is the modern periodic table. There is tellurium and iodine. There is tellurium, Te, and iodine. If you look at the atomic mass, the iodine atomic mass is less than tellurium. So in the Mendeleev, iodine comes here and the tellurium comes in this column. But the problem is with the properties. It does not match with the pattern. So later comes the discovery of proton. And the scientists arrange this table in the increasing number of proton or atomic number. Atomic number is the number of protons. So the modern periodic table is the arrangement of the elements in the increasing order of the number of protons or atomic number. Now if you see this block, so here are some information which you can derive from this block, that like this is the symbol H for hydrogen. On the top, this is the atomic number, this is the atomic mass, this is the hydrogen is the name of the elements, like this. So this is the symbol C for carbon, name carbon, average atomic mass 12.011, atomic number 6. Now the elements whose atomic number are less than 93 in this table, are naturally occurring elements, means they exist naturally on the earth, and the other elements, they are synthetic, means they are made by the scientist. If you look at this table, you see some of the elements are in pink block, some are in green, and some are in blue. So this is the way of classifying the elements in metal, non-metal, and metalloids. Metals are elements. Metals are element that is hard, shiny, and are good conductor of heat and electricity. Hard, shiny, good conductor of heat and electricity. Non-metals are not shiny, malleable, and a poor conductor of heat and electricity. And metalloids. Metalloids are elements, they share some of the properties of metals and some of the properties of non-metals. The element on the left hand side, they are metals. Element on the right hand side, they are non-metals, and the elements that are diagonally, they are metalloids. Except the hydrogen which is on the left hand side, but it's a non-metal. The horizontal row are called periods in periodic table, and they are arranged from 1 to 7. And a vertical column in a periodic table is called a group, and they are from 1 to 18. So there are 18 columns. They are called group or family. Why they are called group? Because in a column all the elements have the same physical and chemical properties, or there is a pattern in their physical or chemical properties. There are mainly 4 groups in a periodic table: alkali metals, alkali metals, alkaline metals, halogen, and noble gases. Alkali metals are the metals or the elements in the group 1 except the hydrogen. These are alkali metal. Okay, they have low melting point, they are highly reactive, and they are soft. So all these elements have these properties: low melting point, highly reactive, and are soft. And the elements in group number 2, they are alkaline metals. They are also highly reactive, but they are less reactive than the alkali metals. Also, when you heat the alkaline metal, they burn in air and produce colorful or bright flames. That's why these metals or the compounds of these metals are used in fireworks. Next comes the halogens. Halogens are the elements in group number 17. This is group number 17. Okay, so this non-metals, these are non-metals, they are blue in color, so these are non-metal except this tennessine TS. And these non-metals are highly reactive and extremely corrosive. And if you go from top to bottom in group number 17, the melting point increases. As you see, fluorine is a gas, chlorine is a gas, bromine is a liquid, and iodine is a solid. Iodine is solid. Both chlorine and iodine are used as disinfectant. As you all know, chlorine is used in swimming pool for killing the bacteria. Now the group number 18th, they are noble gases. They are colorless and odorless gas at room temperature, and they are non-reactive. So they are non-reactive. So let's take the example of argon gas. We use this gas in the bulb. Why we use? Because it prevents the filament metals from corrosion and increase the life of the filament. That's all for today's. Thank you for watching. Keep watching my channel regularly.